Hi, how are you? Today our topic is about avoiding common mistakes. Bushman described three relevant mistakes that must be avoided as a software team performs requirements engineering. He calls them fortuitous flexibility and performance. Fidelity describes the practice of trading functional coverage for all over system quality. There is a tendency in some organizations to equate the quantity of the functions delivered at the earliest possible time with the overall quality of the end product. This is driven in the part by the business stakeholders who think more is better. There is also a tendency of software developers to want to implement easy functions quickly without throw to their quality. The reality is that one of the most common cases of the software project failure is lack of the operational quality, not missing functionality. To avoid this trap, you should initiate a discussion with other stakeholders about the key functions the system requires and ensure that each delivered function exhibits all necessary quality attributes. Flexibility happens when software engineer overload product and adaptations and the configurations facilities overlay. Flexible systems are harder to configure and exhibit poor operational performance. This can be a symptom of the poorly defined system scope. The root cases, however, may be developers who use flexibility as a cover for uncertainty rather than making tough design decisions early. They provide design hooks to allow the additions of the unplanned features. The result is the flexible system that is unnecessarily complex, more difficult to test, and more challenging to manage. Performance occurs when software developers become overly focused on the system performance at the expense of the quality attributes like maintainability, reliability, or security. Systems performance characteristics should be determined as a part of an evaluation of the non-functional software requirements. Performance should conform to the business need for a product and must be compatible with the other systems characters. Summary: requirement engineering tasks are conducted to establish a solid foundation for design and construction requirements. Engineering occurs due to the communication and the modeling activities that have been defined for the generic software processes. Seven distinct requirements engineering functions: inceptions, electrorations, elaboration, negotiation, specification, validation, and the management are conducted by the member of the software team. At project inception, stakeholders establish basic problems, requirements, define overriding project constraints, and addresses major features and the function that must be present for the system to meet its objectives. The information is refined and extended during elections and a requirement gathering activity that makes us a facilitated meeting QAFD and the development of the usage scenarios. Elaborate further expands requirements in a model, a collection of the scenario-based, activity-based, class-based, behavioral, and the flow-oriented elements. The model may reference, analyzes patterns, characteristics of the problem to many that have been seen to reoccur across different applications. As a requirement are identified and the requirements model is being created, the software team and the other project stakeholder negotiate the priority availability and the relative cost of the each requirement. The intent of the negotiation is to develop the realistic project plan in addition to each requirement, and the requirements model as a whole are validated against customer need to ensure that the right system is to be built. Domain analysis. In this discussion of the requirement engineering, we noted that the analysis pattern often occurs across many applications within a specific business domain. If these patterns are defined and categorized in a manner that allows you to recognize and apply them to solve common problems, in creations of the analysis model is expanded. More important, the likelihood of applying design patterns and the executable software components grows. dramatically. This improves time to market and reduces development costs. But how are analyzes patterns and the classes recognized in the first place? Who defines them, categorize them, and rates them for use on subsequent projects? The answer to these questions lie in domain analysis. Smith described domain analysis in the following way. Software domain analysis is the identification, analysis, and the specification of the common requirement from a common specific application domain, typically for use on multiple projects within that application domain. The identification, analysis, and the specification of common reusable capabilities within a specific application domain in terms of common objective classes, sub-assemblies, and the framework. The specification application domain can range from avoiding to bank, from multimedia video games to software embedding with the medical devices. And the role of the domain analysis is to discover and define analysis pattern, analysis classes, and the related information that may be used by many people working on similar but not necessarily the same application in any attempt to identify objects that can be reused across the domain. Now our topic is going to be closed. We will meet in our next video.